this will be taken out over here, and over on this side that will be taken out. So, and I hope you noticed, or maybe we should leave this for the last step here, the distribution of limits. Just put giant parentheses around everything in the meantime. So now we still have problems here. Of course, our goal is to get the h out of the denominator, and it's still in there. So let's see our next course of action. So let's start splitting this up into things that we might find more familiar, and this should be a familiar form, and you'll see why in a minute. So let's okay, I can make that equal to, okay, let's take our limit to the end here. So we're going to make a product. So actually, let me just copy this whole thing. Why am I going crazy? So I have a new fraction here. I'm going to take this out of that fraction, and note that there's a multiplication happening in between these. And what does this look familiar to? It might take you a minute, a couple seconds to recognize it. And let's see what else. Yeah, that's pretty much it. So let's keep that there. Alright, and we also need to split off this side, so let's create a new fraction and make it something familiar that we will recognize. So what can possibly be familiar here? Well, we see a sign of h, and what do we have in the denominator that we can split off from the rest? We have an h. So I hope this is not getting too small for some people. Let me take that. Hope that helps. Alright, so now we have this expression. Let's get rid of what we originally had here. And now I think we're ready to now distribute this limit as h approaches 0. So let me first take everything out of the denominator, well, within this parentheses, and now this limit gets distributed here, here, gets distributed pretty much everywhere. So we did a distribution of in addition and of products, and we're not going to go as far as to put the limit distributing it through quotients. The answer is apparent. So if you haven't recognized this by now, look at one of my first two videos and you will see that the limit as h approaches 0, this is a property we have to memorize. With this, 1 minus cosine h over h is 0, and the limit as h approaches 0, sine of h over h, you should definitely remember this one, is 1, which we proved through the squeeze theorem. Okay, so now let's get rid of this limit by plugging in this value here, and let's get rid of this limit by plugging in this value there. Almost done. And now this no longer matters because it's being multiplied by 0. It's going to go bye-bye. And now all we're left with, the 1 is insignificant. We are left with sine of x over cosine of x times cosine of x. So I imagine some people will do one of two things. They'll go ahead and combine the cosines of x's to make it cosine x squared, but that is not the correct answer. The correct answer in the end is actually separating this into two fractions again. How much time do I have left? Make this into two videos. So 1 over cosine x. So we took the cosine x away from there, and now we know, of course, that this becomes finally sine over cosine becomes tangent x times 1 over cosine x, which is secant x. And that is what we were originally told. The problem, well, the answer was, you might see it the other way around, secant x times tangent x doesn't make a difference. So we have the answer to this. Function of x equals secant x. We have found the derivative. And now let me stop this video and make another one on finding the derivative of function of cosecant x. See you in the next video.